All right, welcome to assessment number 2 in the Coursera Precalculus, module 1. Okay, we have common functions. Let's go ahead and roll in, close, start. 10 problems. So I'll start with number 1. Make sure that's rolling. Let me just double check. Yep, okay. So we have g of x equals x squared plus 3 plus x cubed. What type of function is g of x? Well, the highest power is a 3, so it's cubic. 2. What type of function is the graph? It's going to drop here. Never crosses the x-axis. And as soon as it crosses over into the positive x values, it shoots off to infinity real quick. Exponential. Which of the following functions, so 3, which has domain negative infinity to infinity? A, B, C, D, E. A, h of x equals x cubed. F of x equals 2x squared plus 3x minus 1. M of x equals square root of x plus 2. G of x equals 1 over x squared. K of x equals 4e to the x. So negative infinity to infinity, so that's domain, that is the x values. Which of these functions has x values from negative infinity to infinity that are allowable for the function? Well, the first one does, it's cubic. Second one does, it's quadratic. The third one does not. You cannot have the value of the square root be a negative. So once x hits negative, less than negative 2, this no longer can map onto the graph. G of x, 1 over x squared. This one has all but x equals 0. So that is not negative infinity to infinity. It's undefined at 0, 0. And then this one, yes, exponential has a domain of negative infinity to infinity. It just never crosses the y-axis. Which of the, so for 4, which has infinite many x intercepts? We have A, B, C, D. We have P of x, 1 over x. We have, K of x, 10x cubed. H of x, e to the 2x. F of x, so 1 over x has no x-intercepts. It never crosses the x-axis. So not that one. k of x is 10x cubed. It only crosses the x-axis once. H of x is a positive exponential function. It'll never cross the x-axis, so 0. And the greatest value of x I feel like it would be only 1. Let me just see. Let's see. Oh, that's tough. I'm going to say it's infinite. I didn't think about this. So the graph of this, I'm going to show the graph of what this looks like. So no. This one, I draw the graph, 0, 1. Technically, it crosses the axis infinitely many times between 0 and 1. Any number between 0 and 1 will have a y value of 0. So I'm going to say that that is infinitely many. Okay, that's pretty tricky. I've never used that function before, so I'm still getting used to it. Compute 15 over 4. The greatest integer, 15 over 4. Well, 15 over 4, 12 over 4, 15 over 4, 16 over 4, that's 3, that's 4, so it's 3. Okay, 6. F of x equals 3x squared, x is less than -1, 5x minus 4, -1 is less than or equal to x is less than 3, and absolute value of x plus 1, 3 is less than or equal to x. Find f of -1. So when x is -1, we will use the second equation. So f of -1 equals 5, -1 minus 4 equals -5 minus 4, -9. Okay, next page, 7. What is the range of f of x equals x squared plus 2? So I'm going to just do a brief little example. F of -1 equals -1 squared plus 2 equals 1 plus 2 equals 3. F of 0 equals 0 squared plus 2. 0 plus 2 equals 2. F of 1 equals 1 squared plus 2 equals 1 plus 2 equals 3. So the lowest it gets is 2. F of y equals 2. So this will be 2 to infinity, because it's a positive x squared. So it's going to go to infinity, positive infinity, both negative and positive. So, okay. 2 is infinity. 8. What is the range of g of x equals square root x plus 3? So x cannot be less than 0. So the domain equals 0 to infinity. The range, so starting at 0 is 3. And as x goes to infinity, y goes to infinity. So bracket 3, infinity. Okay, 9. What is the domain h of x equals x squared plus 1? Note, x squared cannot be less than, or cannot be equal to, or cannot be less than cannot be less than 0. So let's just plug in a couple values. F of negative 1 equals negative 1 squared plus 1 equals square root of 1 plus 1 equals root 2. F of 0 equals 0 squared plus 1 equals 0 plus 1 equals square root 1 equals 1. F of 1 equals square root 1 squared plus 1 equals square root of 1 plus 1 equals root 2. So here x can be negative, x can be positive. So the domain, oops. I don't know why I did that. Domain, I'm not looking for the range. Negative infinity to infinity. All x values, all, yeah. Let me just double check that. Okay. And 10. What is the domain of ln x plus 1? We know that the input x plus 1 cannot be less than 0. Because when that happens, we get weird stuff. So when x equals -1, so the domain will be -1, infinity. Uh-oh. Which one did I get wrong? I got one wrong somehow. Oh, what? I accidentally clicked m of x. So even though I said, so I got it right on here. So I did that. I said this wasn't it, but I still clicked it. Okay. Good enough for me.